a second, please. Oops. So, to somehow continue the storyline the two presenters started, I neither have anything to show you here, nor I have some videos. So I only have slides. So we will try to make it interesting just with it, okay? So, as I said, my name is Aleksey Kolotnikov. I'm Supply Planning Director in Danone, Russia. And 2 years ago, we started the project for complete modeling of our supply chain with the Lamasoft company. So today I will be talking about how it went, what was the idea behind the challenge, what worked, what didn't work, and what we've learned out of it. But let's, okay. So let's first talk about what Danone Russia is itself. I think normally Danone is associated with such products as like yogurts, curd desserts, maybe Actimel brand. So the specific of those brands is that they're more or less, they have rather high shelf life, around 40 days, which allows to source long distances from one source. Several years ago, Danone acquired in Russia. Danone acquired the big local player who was selling traditional milk and milk products. Whose the specifics of traditional milk is that the shelf life is much shorter. It's about 10 to 14 days. The sales volumes of this player was 3 times bigger than the core Danone brands, and the real operational nightmare and the challenge appeared after the acquisition was done. So what are we talking about? Just to give you the scale, we need to cover the whole Russia with those products. And just to give you the scale, the territory is around 7,000 kilometers long. To serve it with milk, we have 20 manufacturing plants, 50 warehouses across the country, and we have 2 big dominating factors. So first is, as I said, the shelf life. The majority of the product that we produce and sell is from 10, 14 to 40 days. So the perspective and the challenge of the expiration and the waste of product is at the very top of the agenda. And also, it all comes from milk. So the milk market, the milk availability, and the milk price plays one of the dominant roles in the whole supply chain organization. Okay, so what is the challenge? As I said, we have 20 production plants, a lot of warehouses. Each plant can produce, and approximately 500 of SKUs. Each plant is able to produce, so one SKU can be produced at several plants. Not on all of them, but there is a many-to-many relationship. And potentially you can produce it here, you can produce it there. The question is where to produce. What would be the best and optimal way to produce the required amount of products, and how then to transport it through the logistics network we have to the end warehouse of the from which it will be served to the retail. So to decide upon that, the decision has to be based upon many very interdependent factors. So first, it's of course the demand volumes, the forecast, and how it is distributed geographically, the production capacities of the plants, and the minimum batch restrictions and other restrictions that the production site might have, respecting on the particular product and SKU. Third one is milk availability and the price condition on that. Then the fourth CSL states for availability, the service level that we are giving to the customers. And PPD is acronym for the waste, how much of the product is getting wasted, actually. And 5, of course, is cost implication. So it's very difficult in such a complex operational environment. It's very difficult to make the right choice manually. So before we had a system, we only could, actually we used the first and second, so we of course took the demand, we knew the production capacity, and we sort of touched how it would affect the service and waste level. But we didn't have means to account for milk, and by the way, the milk is contributing the biggest portion of the cost. And overall cost, even industrial cost, as a perspective, was almost missing from our decision-making process. So that's when we understood we need a solid software-based approach to manage those questions. So this is how we formulated the task. So we have milk farms that are defined as, some availability of milk and the price they give, and location, of course. We have the list of production plants, and we have the final warehouses. And we need to optimize the total cost by deciding what to produce where, which is the production plant, how to transport it after it is produced to the end warehouse, and to do it in a way so that the service level and the waste amount is balanced in a best way. So overall, the sourcing problem definition, as we call it, is how to identify the optimal combination of production and transportation plants through the supply chain, so that we minimize the total cost, but still keep the KPIs, which is the service and the waste, in good shape, in balance. So as I said, we have chosen LlamaSoft as a software provider, and after a series of brainstorming and understanding the complexity of the problem and how it is to be tackled, the next high-level idea appeared. So the solution consists of 2 models. One is optimizer, second is simulator. So why 2? Why not 1? Why optimizer is not enough? The answer to this is the volatility that comes from the market, and especially the management of the waste that we need to keep in mind. So as we know, the optimizational algorithms are based on the deterministic mathematics, and they cannot take into consideration the volatility. Volatility is not cannot be handled by deterministic mathematics. So to manage that, we need some other approach, and the other approach is the simulator. So simulator is what it is. The idea is very simple. You have your plant, production plant. You have your warehouse, and let's say you set some rules that the production of the SKU is happening every second day. The transportation to the warehouse happens 3 times a week, let's say. You have your forecast of the sales from this warehouse. That's the starting point. And then you can say, hey, I know my forecast, and I know that the forecast is wrong. Historically, I know that there is some forecast accuracy to the real orders incoming. If you have those parameters known, you can ask a system to generate the sequence of orders that would be different from the forecast, but still be in line with the overall statistical forecast accuracy you have. Right? So if you put those orders to the system, you can just play it one by one, day by day, all the steps of the whole story. So first you get the forecast. The forecast is transformed to the production plan as per schedule set. This is then moved as per set schedule to the warehouse. And here you see the real order coming. Okay. This approach allows to play and simulate how much of the product will be wasted and what would be the service level, much closer to the reality rather than some other empiric approaches to somehow calculate that on the high level. So with that idea in mind, we thought of the following high-level architecture of the solution. So we have the optimizer that tries to build the optimal production and transportation plan and gives you the solution. So this, from the optimizer, we have an output. This solution is supposed to be the most optimal in terms of the cost perspective, and from some high-level rough assumption on what would it be with the service and PPD. Then we take this hypothesis of the perfect plan and put it into the simulator. When you run it through the simulator, it gives you much more precise answer whether, okay, you have this plan that minimizes the cost, but what about the real service and waste? Does it still, is it still kept in balance? Is it affordable to have such a balance or not? And then if it is not, you correct some assumptions, you put some additional constraints and go back to the optimization so that it gives you a new hypothesis. And then you run it again through the simulation. So this is a cycle in which you get your hypothesis, you check it, you verify it in the simulator, you correct it, and then it's done. That's the ideal and most optimal plan that you might have. So this was the initial idea, how we built it. Now, a couple of words more on the architecture, how we thought of it. So you can see the normal slide. So we have our supply chain consists of, as everyone's, from supplier to the production plant to the warehouse, might be the second warehouse, and then to the customer. So we did not intend to cover the transportation from the end warehouse to the customer. We limited the scope of what we're trying to optimize by starting with a supplier, which is a milk supplier actually, and ending with the final warehouse from which the customer is served. Okay. So the whole supply chain was supposed to be put into the optimizer scope. So we took from milk to the end warehouse, we wanted to optimize the flows. For simulation purposes, we didn't take milk. It was too much complex. We wanted to simulate the transportation, how the product goes from production to the warehouse, exactly for the purpose of having the right understanding and checking the service and waste balance. And also we initially tried to put some production simulation in place as well. So what does it mean? In optimization, you can not go to all the complexity of the production process. You can simulate it, you can model it deep, but still not very deep to check the real, from one tank, how it goes to another tank, and then it goes to the packaging line. It is unfortunately not possible to do by means of the optimization of software. So as we thought, there might be some bottlenecks or some impediments that might be not handled by the optimization model. We wanted to simulate the whole process. So just from the very beginning, we failed in here. We didn't do that. By that time, there were no mechanism in the software to do that correctly, so we just omitted it. But the rest is successful. So optimizer works, and the simulation for the transportation is in place. So inside the optimizer, we had three big blocks that we wanted to model. So first is industrial. This is the capacity that we have, how they react to a different mix of products if it is put, when the production site produces the mix A. Its output capacity is 1, let's say. If it is filled with another mix of products, it might be different because of the different packs, different limitations and constraints that put on the sequencing of the production. So all those things were to be put into model to be adequately accounted for. The second big block is milk sourcing, which was extremely complex because you can. It's not only the milk availability and the milk prices that you need to account for. It's also different recipes that you can use for producing the same product. You can do it directly from milk. You can buy cream. You can buy butter and mix the fat and proteins in different ways with different recipes. So. This was extremely important to model all those features. The third one is the transportation and warehouse. Now, to this block, well, if you look at the P&L of Danone, we know that the transportation costs much less than the rest of the rest of the statements. So we did some modeling of the transportation, but it was not that rigor as for production and for milk. So we did it. The project was going for 1 year. And initially, we were planning approximately that time. What are the results? What we now have that we didn't have, and what do we know now? We are now able to find solutions that were absolutely not evident from the glance. So I'm bringing you here the network that we had, and one of the optimization networks. So you see, as was back the network, it is completely messy. So you can, when you're looking at it, you don't know what to do at all. The optimized scenario looks the same. So normally, when we're talking about the optimization with some software, at least I was used to the pictures like you have some messy flows when you do the transportation optimization. Then you do the greenfield research, and then all those flows get streamlined, right? So the as was and as is visibly different. With the production optimization that we need to do, it's absolutely not like that. So you still have those 20 plants, you still have those huge amount of constraints and at each site. And the solution that gives you some saving is not at all straightforward as it is supposed to be for the, let's say, transportation optimization. So my message here is that now we are able, inside those mess, to create another messy scenario, but that gives us savings. Second, what is important? When you model and when you try to solve different, when you search for finding a best scenario, you start to feel the big forces that dominate your supply chain overall. And the system helps you to fill it, so that you are able to sense your supply chain much better. And I will show you on the next slide. I will show you how we use it. But the big value that the system has, it really shows you what is your big forces and big pillars inside those huge amount of factors and particular business cases. So what do we do with the tool? How we use it? Actually, in three ways. Starting from the very routine, we have our S&OP process where we need to match the demand and the supply. Yeah, normal situation. So with the system, if we do not allow it to optimize anything, but just fix the current sourcing and current transportation patterns, you fix it and you put the demand through it, you can see what are the limitations you have, how much you cannot produce inside your current sourcing, what you have to react upon right now just to make sure the sales of tomorrow will happen. So that's first. We use it as a system to check if, in a S&OP process, if our current sourcing fulfills its task to produce what is needed. Second, we can calculate the special cases. Let's say we don't want to reshuffle everything right now. We have different categories of production, different products to produce, the different categories. And there is some event triggering the necessity of changing for, let's say, one of them. So we produce milk and we produce butter. We produce butter in several locations across the country. And we need to do something with this because, I don't know, one of the line is broken. So what we can do? We can fix the whole, all the rest of the sourcing as it is now and open up for optimization only butter, let's say. Then it will give you the answer what to do with this particular butter right now, how to optimize, optimally make a change that would fit into the rest of the supply chain that is, well, unstoppably working. That's second. And third, actually, this is the main purpose of the whole solution, is the strategic optimization of the operational landscape. So you can open everything and say, show me what would my supply chain need to be, where are the plants, where are the warehouses, to serve the demand we know might happen. Okay? This is the most actually complex one. Now, what I want also to show is the system is here. It models, it gives the results. How to arrange, to construct a work around the system so it can really squeeze the essence out of it. The optimization is just a mathematics. So you give your inputs, you ask it to optimize, and it will reshuffle everything. It will reshuffle everything. So it will be millions of changes that are practically unimplementable because of the cost, because of some other factors that you cannot put into the system. So the pure result out of the system is never can never be implemented in a straightforward way. But you need to do something with it, and that's what we've learned how to work actually. So what do you do in the system? You set the task. It might be full strategic optimization. It might be the several cases that you need. You set the task. You get the result from the system, and you see how many reshuffling was done for the system. then the person who is working with it, his task is to actually understand what is the force behind that the system in current conditions tries to utilize. What is it that around which it makes all the reshuffles? What is the change that is the biggest dominant to the saving that the system proposed? So this is done outside of the system, actually. And this person, this analytics who works with strategic optimization, has to understand it and then formulate and frame another request to the system asking the system to calculate what would it be if we go to another scenario, not what you proposed initially, but what we thought of by ourselves, that would use the same force as the system tried to use in the fully open calculation. And if the analytics is good, if he managed to take it from the system and managed to understand what would be the one change or one or two changes that would be giving almost the same result, then it works. So let's say out of the system in fully open condition we get the result and the saving of 100 and millions of reshuffling. Then the analytics looks for one or two changes, put it into the scenario, the rest being untouched. And if he gets out of the calculation 80, then it's a success. Then he has done his job and the system helped with it. So overall, what I also probably want to say that there were words about supply chain and financials do not understanding each other sometimes. That's true, and we've been through that as well. So I think it's everywhere. So the side effect of the implementation, the thorough implementation of such a system is that you inevitably force everybody onto the same foundation of the definitions. Both financials, supply chain, and the Rosenbach and milk teams as well. And even if you don't try to solve all the problems inside the system, you have this foundation that allows you to brainstorm and to align on the white paper much more, much faster and with much bigger common sense inside of what you are speaking to each other and the decision that you collaboratively take. So that's a side effect of the system. Overall, I think that the implementation of this whole story moved the capability of the organization as a whole to manage the different types of supply chain quite high, at least a step above of what it was 2 years ago. We are still in the process of utilizing this thing to the full. It has a great potential, but we are still on the curve to learn how to use it to the full, how to squeeze the essence, how to squeeze the value out of it. But we have gotten a lot already by now. So practically this is it. Thank you.
Thank you, Aleksey. I thought first I'd check anyone in the audience who has a question. Yeah, we have a question. A mic coming there.
I guess first, just congratulations on this journey, right? I think we as an organization, Nokia, just embarking on this as well. My question to you is, what was the effort required to go down this journey, right? Because collecting the data, the operational data, the transportation data, the SLAs, et cetera, I can imagine is no small effort. So how much effort is actually required in doing this? How many people?
Yeah, I
work on
understand.
it?
That's a question actually on master data, on how we collect it and how we put it all together. So it's a huge effort. Of course, it's a huge effort, but we knew it from the very beginning. That's why we scaled the year. So the initial thought was that some good thing can be done in a year period. And it might not be fully correct at the end, but it will have, I don't know, 80% of the correctness that will give a value. But from the very beginning, knowing that the challenge of master data will arrive, just to tell you, we did it for a year. The first 3 months, we were developing the concept of proof, right? So actually the logic. And then for half a year, we filled it with master data. So it's been a huge effort done to collect everything from production, transportation, financials, milk. And as I said, the whole journey, well, combined us and made us a better team that we used to be, partially from this. Because when we asked for master data from different departments, you need to get through to it to understand what are those data meaning actually, right? And that's also part of building the team. But you are right, it's a challenge, but we were ready for the challenge, I would say.
Good, prepared. That's a good objective. Anyone else? I have a question, and I was received a question, because before automation and so forth, what capacity did Danone have when the company overall worked manually? And how many scenarios were you actually able to analyze per month?
Well, the capacity, well, the overall capacity after the project actually decreased. But to be honest, it was all about consolidating the infrastructure, closing plants. Okay, so you need to find where to close it or where to remove the line, so that the overall demand is not harmed. So the overall capacity, if we're talking about the production capacity, it shrinked a bit, but without harm to the business. If we're talking about the capacity of the decision making, it increased very significantly just because we started to better understand what we manage and how to manage it.
And I also know you showed us the solution design, and I don't know if it's that much of importance, but you mentioned that you failed in production simulation. Do you compensate that in any way, or is it not necessary?
Yeah, with a person who does it when it is needed. Yes.
Okay. And bearing in mind, your knowledge now and showing us this scenario with supply chain, what do you foresee as a trend or what sort of growth when it comes to supply chain management, let's say in 5 years?
Well, again, I can be talking about the trends that I can see in Russia only. So the first, there is a, as our GM says, street fighting for volumes right now going on. And in the frame of this street fighting, the sales become much more volatile. So there is a sales not like that, but like that, much more. And supply chain especially in the food industry of such a short shelf life has to respond, has to adapt to still fulfill its task for giving the service at the affordable cost. And to do that, you need to become much more flexible, and you need to feel and understand what is your supply chain able to do. And the supply chain is able to do a lot. So transportation will go wherever you tell it. The warehouse will keep whatever you tell it. The question is how you manage. What is your capability of flexibly playing around this thing? And I think that the competitive advantage of the companies will arise if they continue to learn how to use what they have. So this thing is of course the key, one of the keys on this learning path.
Interesting. So last out, any more questions? There we have one in the corner. Perfect. A mic coming there.
I have a question about your choice to not include the warehouse locations and the distribution in the model. Well, you had the locations in there, but they were fixed. By taking that decision, you're more or less assuming that your warehouses is already in the sweet spot between your manufacturing network and your consumption network. Is that a... Could you tell us a little bit about the rationale behind the decision not to optimize on that end, and maybe tell us if you, knowing what you know today, is regretting that decision?
I understand the question. Can it be switched back?
Is it up? Yeah?
Just, I want to show the slide just to make sure I understand the question correctly, okay?
I'm not understanding. What does he need to do?
So open it. Okay.
Perfect.
Okay, so the question is, if I understand correctly, why did we limit ourselves to the end warehouse and did not continue to the end customers, right? So there are two perspectives, actually. First, we have our the shipment to the customer has to happen within 24 hours. So that actually limits, it's on the trade terms that we have with our customers. And we have a base of the customers, right? So actually this limits the flexibility to remove warehouses from the network. You need to have it there just to be able to serve this 24 within those 24, right? So potentially, there is some potential in you know, a bit shifting the warehouses, right? Combining maybe two in one. It is, but we by then well took a choice to leave it for the future. Okay? Just because we wanted the rather immediate results on the footprint of the industrial footprint that we have now, what we can squeeze out of it right now. Relocating the warehouses is costly. Building new production sites is costly. Closing ones is not costly. Okay? So the question, the immediate request from the management was, what can we do with it right now? Okay? Now we are starting to think of extending the angle that we're trying to put into the thought, exactly to what you were asking for.
Okay, thank you for that explanation, and thank you very much, Aleksey.